To find equivalent fractions, you have two choices of operations. You can use either multiplication or division. In the case of number 26, to get from 7 to 14, you would have to multiply 7 times 2 to get 14. 2 times 2 would give you 4. Or number 27, to get from 8 to 24, you would have to multiply by 3. 7 times 3 is 21. For number 28, since the number 9 gets smaller, that means we're going to be using division. 9 divided by 3 is 3. 12 divided by 3 is 4. Okay. To get from 5 to 25, we would have to divide since the numbers get smaller. So 25 divided by 5 gives us 5, and 10 divided by 5 is 2. So again, you can tell if you use multiplication because the numbers get larger, as in 26 and 27. And when the numbers get smaller, like in 28 and 31, you're going to have to use division. When you're asked to give an equivalent fraction, you can choose either multiplication or division to write your equivalent fraction. So for example, for number 10, if you choose to use division and you know 2 can go into both 2 and 6, then you can divide and get 1/3. Or you can choose to multiply. Now if you multiply, you can multiply by any whole number. So if I choose to multiply both the numerator and denominator by 2, I would get 4/12. Either of these would be acceptable answers as well if you would choose to multiply by a number other than 2. For number 13, since I can divide, I'm going to divide both 4 and 8. 4 goes into both 4 and 8, so I'm going to divide and get 1/2. But again, you could choose multiplication. For number 12, there's nothing that I could divide both 1 and 3 by, so I'm going to multiply them. Again, I can pick any number. I'll pick 4 this time. 1 times 4 is 4. 3 times 4 is 12. So 4/12 is equivalent to 1/3. For number 16, again, division is not an option because I can't divide 2 and 9 by the same number. So I can multiply them by the same number. Go ahead and multiply both of those by 2, which would give me 4/18, which is equivalent to 2/9. Now when you're putting a fraction in simplest form, division is the only operation you can choose. You have to figure out what number can go into both 4 and 10. This is where greatest common factor comes in. If you know the greatest common factor of 4 and 10, you can divide by that. If not, you can break it down and think of what number you know can go into 4. We know 4 can go into 4, but 4 can't go into 10. So we go back and think of what else can go into 4. 2 can go into 4 and 2 can go into 10, so we'll divide by 2. 4 divided by 2 is 2. 10 divided by 2 is 5. Then we ask, can anything go into both 2 and 5? There's no number that both 2 and 5 can both be divided by, so 2/5 is our reduced answer. For number 16, I have to think of what can go into both 8 and 20. Well, I know 8 can go into 8, but it can't go into 20. I know 4 can go into 8, 4 can go into 20, so I'll divide by 4. 8 divided by 4 is 2, 20 divided by 4 is 5. And I ask, can anything go into both 2 and 5? No, so it is reduced. Now I want to show you on this one. If you would have chosen to divide 8 and 20 both by 2 instead of 4, that would have been fine. You would have gotten 4/10. But when you ask yourself, can anything go into both 4 and 10? Yes, 2 can. So you would have to divide again by 2. And notice you would get the same answer, 2/5. For number 17, when I ask, I know 12 can go into 12. Can 12 go into 36? Yes. So I would divide both sides by 12. 12 goes into 12 once. 12 goes into 36 3 times. When you have a numerator of 1, the fraction cannot be reduced, so 1/3 is in simplest form. Now, if you would have chosen to divide by 2 or by 3 or by 4, another number other than 12, once again, that's fine. You just have to continue to reduce until the fraction cannot be reduced anymore. On one like number 18, whenever the numerator and denominator are the same, it equals 1 whole, because this means you have 8 out of 8 pieces, which would mean you would have the whole thing. Now we're going to change mixed numbers to improper fractions and improper fractions into mixed numbers. First of all, to change a mixed number into an improper fraction, you would multiply the denominator times the whole number. 4 times 4 is 16. Then you would add 1, and that would give you 17. The denominator stays the same. On number 5, we would multiply 5 times 3, which is 15, and add 2, which would give us 17. The denominator stays the same. 7 times 2 is 14, plus 3 would give me 17. The denominator 7 stays the same. Now, to change an improper fraction to a mixed number, we have to keep in mind that this this fraction line stands for division. So we would have to divide 5 by 2, or another way to think of it is you would divide 2 into 5. 2 goes into 5 2 times with a remainder of 1. So our answer would be 2 wholes, and then you put the remainder over the divisor, and that gives you a mixed number, 2 1/2. And then you have to check to see if 1/2 can be reduced, but it can't. So that would be your answer, 2 1/2. On number 19, we have 10/3, so we have to divide 3 into 10. When we divide 3 into 10, it goes 3 times with a remainder of 1. We have to put the remainder over the divisor to make a mixed number, 3 1/3. Then you ask, can 1/3 be reduced? But it can't, so 3 1/3 would be your final answer. On one like 12/4, we divide 4 into 12. Now when we divide 4 into 12, that goes evenly 3 times. There's no remainder. So our answer would then just be 3. If we have one like 10/4 that we need to make into a mixed number, we divide 4 into 10. Of course, this division can be done mentally. 4 goes into 10 2 times with the remainder of 2. Then we put the remainder over the divisor and we get 2 2/4. And then we ask, can 2/4 be reduced? And it can. Now when you reduce a mixed number, it's just like reducing a fraction, except you have to bring the whole number over. 2 can go into both 2 and 4, so we divide them both by 2. 2 goes into 2 once, 2 goes into 4 2 times, so 2 1/2 would be our answer.